Welcome back to School's Not Out, your daily classroom for CSEC Math. We're talking about bearings, so let's get to our lesson.
When we're driving, we have stop signs and, you have your stoplight and you're driving and you're like, okay, I need to go right. Okay, I need to go left. When I was younger, someone told me that there were even roads in the sky. So maybe there are roads in the sky.
Well, I've never been a pilot, but I'm sure that when I was up there, I never see a stop sign. But let's look at this. Let's look at this. What about on the sea where we have some boats, we have ships, are there stop signs there? You have a stoplight. What's going on there?
Well, guess what? You see, for the ships now, or the boats, I don't think there are any stop signs. And clearly, we can't have roads on the sea. I've never seen any, I'm wondering. But guess what? I remember something. I have this fisherman, he's good. I remember one day he said he was lost at sea. And he used something called a compass, I'm remembering now. So he used the compass to figure out where he is and where he needed to go. So maybe the compass have something to do with it,
I think the coffee's starting to kick in now. Yes, girl.
Yeah.
So it's definitely a compass that they're using to help to navigate the sky and the sea.
Oh, yeah,
Yes.
You're right, And also with the compass, I believe there are some measures on it.
Yes.
Which is how the bearings come in.
Exactly how they come in.
So now we're figuring out what exactly is bearings so we can just put it together now.
Yeah, let's talk about it. So a bearing is actually an angular measure clockwise from a northern direction.
Okay, hold on. We want them to actually have the visual represented. So I'm going to sketch.
All right.
So you're saying we have a north.
You have a north line.
So here I'm representing my north line.
We have a point of reference to start.
All right, so we have our north line. And you said to us earlier, we go clockwise direction. Now, when I'm thinking about the clock and going clockwise, I am going in this direction. So my clockwise direction would be this way. So it would start from my reference point where my north pole is right here, and then I would go in a clockwise direction.
Suppose it is that, for our listeners on the radio, suppose we want to tell them about what's happening with the clock. Explain how we'd move clockwise with the clock.
So for listeners on the radio, if we're going to do a clockwise direction, just as how you have 12, and then after 12 you have 1, 2, 3, 4, and the hands of the clock go that direction, you move 12 to 1 to 2 to 3 to 4. That would be the clockwise direction.
Awesome.
So you're going to then now move from the north right to the right. So you're going to the right now to arrive at your clockwise direction.
Good. Bearings also uses 3 digits. So normally when we're looking at a bearing, we're starting off at north, which would be something like 0, 0, 0 degrees. So it's always represented with 3 digits.
Oh, I see, I get it. And guess what? Ooh, there's our compass.
There's our compass. So if we're looking at the compass, tell me what you see, Camille.
Well, based on what you said just now, we have 3 digits, which gives us our bearings. So now we can link it back to bearings. So here we have our compass, which we spoke about earlier. And it's not the compass that you use to draw circles in school. And you're constructing, it's not that compass,
No,
so it's not that compass. This now is a tool. So that compass that we may have thought about, or some students may be thinking about, is not that one that you use to construct circles. This compass is different. It gives a tool and it gives us measurements.
And it also has some cardinality. So we have the 4 main cardinal points: north, south, east, and west. Right? So we're seeing that. North, east, south, west.
All right.
And we are also seeing our 3 figures, or 3 digits on the outside of our compass.
All right.
Now, there's some other points that we'd like to mention to you. So although we have the 4 main cardinal points, in between these points, halfway through, we have what is known as half cardinal points. And that's northeast, 0.45 degrees, southeast, 135 degrees, southwest 225 degrees, and northwest 315 degrees.
You know what's good too? It's good that the northeast, which is our 045 degrees, it's basically halfway. So it is exactly halfway between north and east, right? And then our southeast now, which is 135 degrees, is exactly halfway between our east and our south right there. And then our southwest, which is 225 degrees, is halfway between south and west. And our northwest, which is 315 degrees, is halfway between our north and our west. So this is good. This is very good. But you know what I'm looking at too? Right here, if we link it back to angles, we're realizing that our northeast here is less than 90 degrees. So if it's less than 90 degrees, it's going to be a, what they call it again? It starts with an A. What type of angle is that one again?
It's an acute angle.
Yes, it's an acute angle. And right here now we have 135 degrees, which we know that can be an acute angle, and it's definitely not a right angle, because a right angle measures exactly 90 degrees. So it's more than our 90 degrees, which gives us our obtuse angle. And right here where we have south, it's exactly 180 degrees, which links us to our straight angle, right? So we have already started looking at our bearings to really know what it is. We said that it's a 3-digit figure. And we also recognize that we have a north and we go in a clockwise direction.
Now, why do you think we would have needed to have bearings? What do you think was happening? Now, one of the things that we thought about is that sailors probably had a difficulty communicating their location, right? So you over there, so you over here, so turn left, turn right. What does that mean? That has no meaning. So they needed one fixed way to be able to navigate and give directions, right? So one way they came up with to solve the issue was to measure all angles from a north line going clockwise
direction. Great. And we would have said earlier before we went to the break that bearings is a 3-digit number. All right?
Yes.
All right. So here, activity time, guys. Activity time. Woo-hoo.
All right.
All right.
So here we're looking at a map of Jamaica. So can you see the map?
Yes, I'm seeing the map.
All right. Now, can we identify cardinal directions of a few parishes in relation to Kingston? So we're measuring cardinality, or we're looking at cardinality from Kingston. So let's start off. If I'm in Kingston and I wanted to find out the direction of St. Thomas, for example, where would St. Thomas be?
Well, based on the map of Jamaica now that we're looking at, my reference point, since I would be coming from Kingston and I would be going to St. Thomas, that means I would be going east. So if I'm leaving Kingston to St. Thomas, I would be going east.
All right.
Right, so here I would have my north line, and there I would be going east.
So I'm traveling clockwise.
Great. And
traveling
we're going
clockwise, and we're going east. You notice what type of angle is formed there?
Right angle.
Right angle
is formed right there. All right.
How about St. Catherine?
All right. So if I am at St. Catherine and I need to go, well, not St. Catherine, we need to ensure that we remember where we're coming from. So now we're in Kingston. So I'm coming from Kingston and I'm going to St. Catherine. So which direction would I go? That means I would go west. So I am starting at Kingston, but I would go in a west direction.
All right. So good. How about St. Mary?
That one is easy. Because if I am at Kingston, well, right now I'm in Kingston and I'm going to St. Mary, and I would love to go to St. Mary right now, I know I would be going north. So it is directly going north based on where I am right now in Kingston.
No, I think you've done this before, don't you?
No, but
I can get all them right.
No, man, I love the direction. I love doing directions.
All right. So now let me test out your skills. So COVID Brown went to visit her aunt in Portland Cottage, Clarendon.
That's where I'm from, Clarendon.
So COVID was at the river. You know, we like go to river in Jamaica.
Yeah.
So COVID went to the river and she was given a map to help her to find her way back to her aunt's house. So she was told that C, which is the point here, on the map represented the river, and we want to help COVID get back home. So what bearing should she travel from C to E to get back to her aunt's house? Let's test your skills now.
All right. So now we're going back to what we said bearings is. So going back to what we said bearings is, we know that the first thing we have to do is we are going to establish our north. So that's the first thing that we're going to do. So we know we're coming from C. So COVID here is coming from C. So we're establishing our north. The next thing that we are remembering too is that we're going in a clockwise direction. So remember now, we're going in a clockwise direction. So in a clockwise direction, we are starting right at C, and we have already established our north. So we are now moving from north, going to east. We realize that our aunt's house is not east. We're going to south. We realize that our aunt's house is not, yes, guess what? No, so it's not at east. So now we're at south. But when we look, we realize that E is somewhere, our aunt's house is somewhere between east and south. So now we are trying to look at where exactly it is. So we know that it is somewhere between east and south. So it must be between our 90 degrees and 180 degrees. And here we have it. So here we are looking at our protractor. So we're looking at our protractor. We're using our protractor here to measure the exact bearing of our aunt's house. And here we're seeing it. Great. Brittany is helping us. And we have arrived at 135 degrees. So that is the bearing from C, which is where the river was, to our aunt's house at E. So, Brittany, tell me if I get it. Tell me if I missed out anything. Help me out, help me. Tell me if I get it or if I missed out anything whatsoever.
So, let me ask you a question. You're saying to me that when we're looking at maps, instead of using our compass in math, we use a protractor?
Well, based on what we're doing here, yes. So, yes, if we're on the boat, we're going to be using our tool as the compass right there to give us the direction. But when we're now getting the exact location and the measure here, which is our bearing, of one place to the next, we are using our protractor here.
Okay, good, awesome. So you did a good job with this, and indeed, she would travel 135 degrees from the river back to her aunt's house. So you helped out COVID a lot this morning.
Yes, she found her aunt's house. But guess what? You put me on the spot. So it's your turn now, and guess what we're going to be looking at? We're going to look at a CSEC question. So we're going to look at a CSEC question first. So bam, we're looking at question 1, and here goes.
All right, bring it on.
No problem. The diagram shows the position of 2 hurricane tracking stations, P and Q, relative to a point O. P is on a bearing of 0.25 degrees from O, and OP measures 400 kilometers. Q is on a bearing of 0.80 degrees from P, and PQ measures 700 kilometers. So guess what your question is now? There's your question. So on the diagram, you are going to label the angles that show the bearings of 0.25 degrees and 0.80 degrees. By the way, you remember why we have 0.25 degrees and 0.80 degrees?
I thought it was a challenge. Bearings uses 3 digits.
Oh, great, great, great. So we're on task. We're on task. Great. So your turn now. You're going to be labeling it for us now.
Okay. All right. So you said that we are using O as our reference point, right?
Yes.
And P is on a bearing relative is on a bearing of 0.25 degrees.
Yes.
So I'm at O, and it means that, here we go, we've established our north line. We're going to be measuring 0.25 degrees from O to P, which would be here.
Great.
I would then need to, okay, and then you would label our angle 0.25 degrees.
Good job, good job. So you got the first one right. Let's see if you're going to figure out the second one now.
Girl, this is easy. What you mean?
Man, what
So now we're measuring a bearing from P to Q. So we're measuring from P to Q. Again, we have our north line. So we're measuring 0.80 degrees from P to Q. So it would be from our north line here to point Q.
Hold on. What direction are we supposed to go in again? Which way?
I'm moving in a clockwise
Great.
direction.
So we're going in a clockwise direction. Great, which gives us here. So this is just helping us here what Brittany is showing. So here from P to Q here, we have 0.80 degrees. All right, cool, cool. I give it to you.
You know, in normal times, you'd pop my color because I wouldn't have to pop it.
I give it to you. I give it
All
to you.
right.
I give you this round. I give you this round. But we're going to do our next question. But guess what? Guess what's up with the next question now?
What's up?
You're going to have to help me. So we're going to do it 50-50. All right, so let's try this one. And this one is another CSEC question. But this one is fun. This one never fun a while ago, you know. This one will be fun.
Okay, so let me tell you what we're going to do. A man walks X kilometers due north from point G to point H.
All right, so guess what we're going to do now? I am going to represent it as you speak. So let's go. So he's traveling from where?
A point G to a point H due north.
So
X
he's
kilometers.
traveling from G and he's going north. So I'm doing a sketch of what Brittany is saying. So due north, and he stops where?
At a point H.
H, all right. So we know that right here, Brittany just told us we are going north, all right. So I reach H. What next am I supposed to do now?
And they also told us that he walked X kilometers. So as we go along, we need to label that.
All right, so let's label it. So it's X kilometers, all right.
All right. Now, he then walks X plus 7 kilometers due east from point H to point F.
All right, so I'm starting now at H.
Yes.
And I'm going east.
Due east to a
so
point
I'm going
F.
east. So there I have it. East to a point F.
And the distance he traveled was X plus 7 kilometers.
All right, so it's X plus 7 kilometers from H to F. Okay.
All right. The distance along a straight line from G to F is 13 kilometers.
So all we're going to do now is connect both points.
Point G and point F.
Great. So we're connecting point G to point F.
And this measures 13 kilometers.
All right. This measures 13 kilometers. So there we have it. We started at point G, we stopped at point H, and then he traveled to point F, X plus 7 kilometers more, and then we're also told that the distance between point G and point F gives us 13 kilometers. So whoopee, I got it. That's
Good job.
correct. That's correct. Great.
All right, so now we're asked to write an equation in X which satisfies Pythagoras' theorem.
Lord God, Pythagoras theorem, Pythagoras theorem.
Why them asking us about Pythagoras theorem again? Why?
You know though, but when I look at the triangle here that we have, we are realizing right here that right at point H, so for our persons who are listening on the radio at point H, we are establishing that that's a right angle, which means if it's a right angle, it measures exactly 90 degrees. Now they're asking us to write an equation that satisfies Pythagoras theorem. even though I'm young, when I was much younger, I remember in school they said that as long as you're using Pythagoras theorem, it must be with a right angle triangle. So right here we know it's going to be a right angle triangle.
Okay. No, but that's okay, what's Pythagoras theorem? What's that?
That's a good question, and that's where you need to bail me out now. I'm young, but I'm not so young. Remember I said when I was younger, so bail me out now.
Oh gosh, look how you put me on the spot. Why are you doing that to me? Well, I think, because I'm not really so young myself, but I think that Pythagoras' theorem looks at the relationship between the sides in a right angle triangle. So I think I heard that the hypotenuse squared is equal to the sum of the square of the other lengths of the triangle?
Yes, you never hear. You know. Trust me, you're right on spot. That is indeed correct. So here we have the square of our other length. So we have x squared. Remember now, x kilometers would have been the length from G to H, plus our next length would have given us x plus 7, which is all squared, which now gives us our hypotenuse square, which is our 13 square.
Well, let me ask you a question. How you know that is the hypotenuse?
How I know this is the hypotenuse? Because we already know from long time that the hypotenuse is the longest length, the longest side of the triangle. So the hypotenuse is always the longest side of the triangle.
Okay.
All right, so here we have something looking like an equation so far. We have something, so now we need to simplify it. What did they tell us that we need to bring it to? X squared plus 7x minus 60. All right, no problem, that's a challenge. No problem, man, I got it. So let's go.
All right, do it.
So right here now, first before I even move on, we're recognizing here that we have, let me use a different color for the persons who are watching. So right here we have x plus 7 all square. So we have x plus 7 all square. All right. So watch me now and watch me carefully. So here we have x squared plus. So now we need to figure out what is x plus 7 all square. I don't know if you remember when we used to go to school and we learned it. So we're expanding, right? So x plus 7 all square means that it's x plus 7 in one bracket, x plus 7 in the next bracket. Simple like ABC, right? And we're expanding.
Okay.
So right here in our expanding now, we're using our first term in our first bracket, which is x. So we have x, and we're now using our second bracket. So here we go. So we're just expanding. Okay. Which now gives us our x times our x gives us
x squared.
X squared. Great. Our x times our 7 gives us
7x.
Great. And our
Plus.
7, right. So now we know that is plus. 7 times our x gives us
7x.
All right. And our 7 times our 7 gives us
49.
Great, 49. So all we now need to do is simplify it. So here we have how many x squared terms we have?
Only one.
Great. So we're writing it back down. We only have one, so we have x squared. Now 7 plus 7x plus 7x gives us what?
14x.
Oh, don't worry, you don't have 14 fingers. So it's 14x plus 49.
Very good.
Right, so all we're going to be doing here now is x squared plus our 14x plus 49 equals our 13 square. And all we need to do is simplify. So how many x squared terms we have?
2.
Great, so we have x squared plus x squared gives us
2x squared.
2x squared. Plus our 14x plus 49 gives us 13 squared is what again? 13 times 13 gives us what?
169.
No, man,
What you mean?
169. All right. So it's 169. All right, great. But when we're looking at what you have there, We need to simplify it a little bit further because you have x squared plus 7x minus 60. So we need to simplify it a little bit further. So let's see now. Let's see. So we now have to balance our equation because we have to go figure out what we're doing. All right. So we have 2x squared plus 14x plus 49. But guess what now? When we look on the right-hand side of the equation, we recognize that we have 169. So we have to balance the equation. So we're going to be subtracting 169 from both sides of the equation.
But why you have to do that?
What do you mean why I have to do that?
It can't unbalance.
No, an equation cannot be unbalanced.
Okay.
Remember, an equation, you have to balance the scale. You balance the equation, man. One side, the left-hand side, must be equal to the right-hand side. So let's go. So here now we have 2x squared plus 14x. And now we have 49 minus 169, which gives us minus 60. And we have 169 minus 169, which leaves us with 0.
No, teacher. Well, the maths.
Nice.
You know do the maths, miss.
I'm glad you see it. I'm glad you see it. So you're paying attention. So what I supposed to have right here, so?
I think you know 49 from 169 is 120?
Hold on. Make we do the subtraction.
No, miss. Really?
Make we do the subtraction. So here we have 9 from 9 gives us what? 0. 4 from 6 gives us
2.
And we have 1 left. So you're paying attention,
I can't believe you don't
paying?
me.
No, it's not that I never doubt you, man. I wanted to ensure that you're paying attention. So we're on target. All right, but guess what now? Your equation there says x squared plus 7x minus 60. So we now need to do something with 2x squared plus 14x minus 120 equals 0 to arrive at that equation. Simply, now guess what? We're just looking at all these numbers now. So we're looking at the coefficient right there of x squared is 2. When we look at 14x, the coefficient right there is 14. And our constant there is 120. The highest common factor now of all these 3 numbers is 2. So all we need to do is divide all or each term by 2. So our 2x divided by 2x squared, divided by 2 leaves us with x squared plus our 14x divided by 2 leaves us with 7x. And right here now we have our 120 divided by 2 gives us 60 equal 0 divided by 2 is undefined, so we know it's 0. Bam! Tell me if I get it. Tell me if I get it.
You do a thing,
One
you
man
do
go
a thing, you do a thing.
Go through. One if I get it, go through, man. Go through.
You got it.
No, man, I want to see what you did because I know you worked it out. Took one, man. All right. Yes.
We kind of look like we're on the same path-ish.
Right. So we're getting it. We're getting it. Yeah, we're getting it. Kudos. We get it.
Now, after that, we're asked to now solve the equation to find the distance of GH.
All right. So we're asked to solve the equation, which is our x squared plus 7x minus 60. So we're asked to solve this equation.
To find the distance of GH. So from that, we know that we want to find, we're solving for x.
All right, so we're solving for x. What they call this type of equation again? It starts with a Q, man.
A
We have
Q,
square term.
a Q.
Yeah, man.
Quadratic equation.
Great. So we call it a quadratic equation. Great. So now we have a quadratic equation. Let's see if we can help ourselves out. So the coefficient of A, let me use our black marker here, would be what? 1.
I think it's 1.
Right. Our coefficient of B here would give us
7.
And our constant is?
Negative 60.
Great. So we're on the right ball already. Now, what do you think we're going to do next?
Factor?
Yeah, we need to find some factor. We need to factorize it. Yeah, but
How you do that?
that's what that same thing I'm here looking at. So now we realize that, all right, our coefficient of x squared is 1 and our constant there is negative 60. So now 1 times negative 60 gives us negative 60. So we need to know, so let me write what I'm saying.
I think so.
So it's A times C, which is 1 times negative 60 gives us negative 60.
Yes.
Right,
Yes.
good.
Yes.
So now we need to find two factors that when we work out, we look at the two factors, we multiply them, we arrive at negative 60. But when we look at our B term, we are seeing positive 7. So you can think of two factors of negative 60.
That when I multiply them, I get negative 60.
Great.
But when I add them, I get 7.
Yes, great.
I'm thinking about maybe 12 and 5. But wait, 12 and 5, 17. No, 12 and negative 5.
All right, so you're thinking of, you're right on target. So you're saying plus 12x minus 5x minus 60 to give us 0.
Yes.
Great. So we looked at the factors right there of 60. Right there, we have our factors to be 12 and 5. And we know that it's negative 60 and our B is 7. Great. So now all we need to do is simplify. Right? So let's work it together. So let's go. So we're factorizing now.
So teacher, one question. How you just write down x, miss?
That's why, you know, let me rub it out. Let me rub it out. So let's go. We're factorizing.
Yes.
All right. So now we have x squared plus 12x minus 5x minus 60. So let's factorize. How you think we would get it now?
Are we going to look at the first two terms? Are we going to look at common factors for the first two terms?
Tell me what you want us to look at.
Let's look at the x squared term and the 12x term.
All right, so we're going to be factorizing those two first. So what is the highest common factor between x squared and 12x?
Well, the only thing I see that they have in common is x.
Great job. So it's x. So
Okay.
x squared now divided by x gives you what?
X.
Great. Plus 12x divided by 12 gives you, divided by x gives you what?
12.
All right, good job. Now we're going to the second part here now to give us our minus, I give away the answer. We have here 5x minus 60. What is common between these two?
We're looking at common factors again.
Yes, the highest common factor.
The highest common factor. What do you mean by factor again?
Come on, man, you know it can.
All right, fine.
Yes.
All right, a number that can divide into both 5x and 60 without leaving a remainder.
Thank you.
All right, it's 5. Negative 5?
All right, so we have negative 5. So now we have 5x or negative 5x divided by negative 5 gives us what?
X.
All right, and now we have our negative 60 divided by negative 5 leaves us with what?
A positive 12.
Great job. And all we need to do now is just put them together. So we realize that we have 2x plus 12. So we're just writing back one of them.
So the common factor there is x plus 12.
Right.
Okay.
And the next one now, we realize we have x here. And we have minus 5. And remember, you gave us a keyword, you know, you said solve. We have to solve for x. So now that means we have two different
All right, so we have two factors.
Great. So it's x plus 12 equals 0. And balancing our equation again, because we're solving for x, we would have to subtract 12 from both sides, which leaves us with negative 12. All right. And here we have x minus 5 equals 0. So balancing our equation again, solving for x, we would add 5 to both sides, which leaves us a x minus 5 plus 5 leaves us with 0, so we arrive at x equals 5. So we have negative 12 and we have 5.
But let me ask you a question. We're looking at direction, we're looking at distance, right? And they're asking us to tell the distance of G to H. You're telling me that we have two solutions here, x can either be negative 12 kilometers. But I never hear about that.
Right.
Negative 12 kilometers.
Great job. So I'm happy you're looking. So right here we know that for the here to find the distance for what? G to H, it cannot be negative 12. So we know then without a doubt that it is 5 kilometers.
Okay, I understand now. So
Right.
let's see. You
No,
know, sometimes I forget things, so let's check
I can
it.
close my eyes because I know I got that one lock. See? I tell you, man. Ooh.
You're right-ish again. You're right-ish.
Tell you, man, I got it. All right. And the last part of the question now,
All right, so the last part of the question is asking us to determine the bearing of F from G. So we're determining the bearing of F from G.
All right. So right here now, going back to our original triangle here, our angle is formed right here at G. So because our angle is formed right here at G, let us now look at some properties here of our right angle triangle.
So miss, we can write the actual measure of GH?
Yes, man, we're going to do that. So let's look at it now. So GH was what we found GH to be again? 5 kilometers. Great. So GH, length of GH is no longer X kilometers, but 5 kilometers. So right here now, we're looking at...
Miss, I have one more question.
What's the question?
If GH is 5 kilometers and we know that HF is X plus 5 kilometers, what's HF?
It's not X plus 5, man, but you're on the right track. It's X plus 7. So X plus 7, which is 5 plus 7, gives us what?
12?
12. Great job. So the length now of our HF here would have been 12 kilometers. Great. So we're on the right track. So we now have the length of each side of our right angle triangle. And we are asked, what did they ask us to find again? The bearing of H? The bearing from
G.
So we're coming from
F.
G to F. Right. Great. So
the
we
bearing
now
of
know.
F from G.
Great job. So right here we're looking at it now. So our angle is formed at G.
Yes.
So if our angle is right here at G, we now need to look at the side that is this length. This little FH is what in comparison to angle G, the angle formed at G?
But why are we doing that though? What type of triangle is this again?
It's a right angle triangle.
So with right angle triangle, we know that there are special properties in the right angle triangle that allows us to use some, what's those things called again?
Trigonometric ratios,
Some ratios,
Great.
right? That shows the relationship between an angle forming the right angle triangle and some side of the triangle, don't it?
Nice. So we can find the length of a side or an angle based on the ratios. All right, so let's go now. So we know here that our opposite, so here, FH would have been what?
So we know that HF is directly opposite or angle formed. So HF is opposite angle.
It's FH, yes.
Angle G.
It's opposite,
yes.
Right?
We also know that GH, which runs right alongside our angle, is adjacent to angle G.
So GH, which is adjacent.
Yes.
So now, all we need to do is put them together. So we're looking at opposite and we're looking at adjacent. Which one of the trig ratios you think give us that now?
Opposite and adjacent. I think it's the T1. What the T1 name again?
Tangent. So it's tan. So it's tan theta gives us our opposite divided by our adjacent. Which gives us our opposite was what again? 12 kilometers?
Yes.
Divided by our 5 kilometers. So let's check if we are on the right track so far, because we would have worked it out before. So we know that here to find the angle theta, it would have been tan inverse of 12 divided by 5 to have arrived at our bearing 67.4 degrees. Great job. So guess what, guys? We would have done so much for you so far. It's your turn now. You're going to get a homework to try. So look at the homework for today. So here's the homework.
All right, so for homework, you're going to look at the diagram that shows the relative positions of 3 reservoirs, B, F, and G. All on level ground. The distance of BF is 32 kilometers and FG is 55 kilometers. An angle is formed at BFG, or an angle is formed at F, which measures 103 degrees. F is on a bearing of 042 degrees from B.
Great. So the homework, no, go back, man. They didn't get the homework. Go back, man. Nice. Go back. They didn't get the homework. So that's the homework. The question right there, it says determine the bearings of B from F. So that's the homework that they're going to do. So let's give them 30 seconds because we're going to wrap up, you know. So let's give them 30 seconds to maybe, you know.
Take a picture. Take a picture.
Yeah, man, take a picture. So let's give them 30 seconds to take the picture and then we just do the wrap up. So remember, guys, that today we were looking at bearings. Bearings, as we would have said, the 30 seconds expire, so it's our time now. Nice.
All right, fine.
So bearings now is an angle measured clockwise from the north direction, which we know as north, and bearing is 3 digits. So it's expressed in 3 digits.